Algebra 1, Section 12.2, Simplifying Rational Expressions. Much like I did with Section 11.1, it really is just going to be a whole bunch of practice. I think I've picked out about 15 problems here that we're just going to power through a bunch of these, get you a whole bunch of exposure to the different things that can happen and how these will simplify. Again, sorry that this comes up blurry on my star board. It's the best I can do. I did make this worksheet available in the Chapter 12 folder. So if you'd like to see a clearer copy, you certainly can access that and open it on your computer or print it out even if you like. And we'll get through this as quickly as I can here. I didn't practice this once before I went through, so we'll see how it goes. But I think we can do this fairly quickly. We'll shoot for 20 minutes. All right, so the first 8, we're going to do all of these. They're all just a little bit different, and we're going to knock them out quickly here. Basically, what you need to realize is that not only does 6/18 reduce, but also x to the 4th over x squared, you can apply a power rule, division of powers, or I guess it would be quotient of powers, that we would have learned about in Chapter 8. So 6/18 would reduce to 1/3. X to the 4th over x squared would be like saying x to the 4 minus 2, or how others will think of this. And really, as I've said before, there's kind of value in seeing this both ways. Yeah, great to know the rule. X to the 4 minus 2 is x squared. But also, if you see this as x times x times x times x, or really it's 6 times x times x times x times x, over 18 times x, then the pairs of x's will cancel top to bottom. That's why it's x squared, because that's why it's a subtraction, because 2 of these got knocked out. 4 minus 2 leaves you with these 2. Anyway, our answer would be x squared in the numerator and then just 3 in the denominator, right? 6/18 is 1/3. X to the 4th over x squared is x squared. That's like saying 1 times x squared over 3 times nothing. 3 times x to the 0, which is 1. So x squared over 3. Okay, on this one, 15/25 would reduce to 3/5. Here you'd have a to the 2 minus 4. So this would be like, kind of like saying 3a to the negative 2 over 5, right? Except we learned in Chapter 8, you don't leave that negative, you move it and lose it. So that's actually going to be 3 over 5a squared. 3 is going to stay. The a to the negative 2 is going to move and become a to the positive 2, 3 over 5a squared. Again, if you had listed them out, a times a in the numerator, a times a times a times a in the denominator, and then wiped out the 2 pairs, if you will, top to bottom, you'd be left with 2 a's in the bottom. That's where your a squared comes from. Okay, next, 32 over 48 actually reduces to 2/3. H to the 3rd over h squared would just be h to the 1st power. This would be 2h over 3. 2h to the 1st over 3. The next one, similar. So I'll just write the answer. You can verify it on your own if you like. 4 over 7n squared. Okay, the next one, here's where we're going to get into some factoring. That numerator there is divisible, is factorable by 3. Both terms in the numerator can be divided by 3. So we should take the 3 out, and that would leave us with x minus 2 over 6. And then 3/6 reduces to 1/2. So really then this is just x minus 2. We don't really have to bother with the 1 over 2. This is completely simplified. X minus 2 over 2. Again, 3 over 6 is 1/2. 1 times this parenthesis doesn't require us to have the parenthesis anymore. It's just x minus 2, and then 6 became 2 when we reduced to 3 over 6. Okay. Now, similar but different, in number 6, you can divide something out, but that something is an x. And if you divide x squared by x, you're left with x. If you divide negative 2x by x, you're left with just negative 2. Okay. And now it's the x's that will cancel. Yes, the x's will just simplify. This is 2 things being multiplied, so you could knock those out, right? It's not going to simplify with anything in the parenthesis. Some people think you can do that, but that's multiple terms here. But these parentheses are counting it as a quantity. That quantity is being multiplied by x. All that's being divided by x, so the x's would cancel. You're left with just x minus 2 as a simplified answer. The next one, we can not only take out a number and or a variable. Actually, in this case, you can take out both. Factoring. You can factor out a 2t, which would leave you with 2t minus 1 over 2t. And yes, the 2's and the t's would cancel, or you might just say the 2 t's cancel, and you are to write 2t minus 1 as your solution. And then number 8, you can definitely divide out an a squared there. GCF, chapter 8, would leave us with a minus 2. In the denominator, you can divide out a 2a, which would leave you then with a minus 2. And now what will cancel will be the a minus 2's and something else also, but notice what's in parentheses there, you can knock those out. Again, it's a quantity being multiplied by a squared in the numerator, same quantity being multiplied by 2a in the denominator. Those quantities being the same thing, you can cancel them right out. Also, a squared over a to the first power would cancel this out, and this would be a 1. So this is just a over 2. You know, something, I guess this is the right time to bring this up too. Something that would be a worthwhile activity is take a problem like that one, number 8 that we just did, and plug in a 3 for a, and see what 3 to the third minus 2 times 3 to the second all over 2 times 3 to the second minus 4 times 3. See what it is, okay? And it'll come out to 3 over 2, okay? Plug in a 19, and it'll do the same. You'll get 19 over 2, because the answer is a over 2. I'm saying pick a real value, plug it in for a, and see if it doesn't simplify down to that number over 2, like that one did. All right, we're skipping 9, moving to 10. 32 over 24 is 4/3. X to the third over x would be x squared. Y to the second over y to the fourth would be y to the negative 2, or as a denominator of y squared. Similar to problems we're seeing above, we're just getting a little bit longer in the terms, both numerator and denominator. So this is 4x squared, everything simplified, 4x squared over 3y squared. Simplify the numbers, simplify the x's, simplify the y's, and this is what you have left. And somebody just came to my door and waved at me. I don't know who it even is. 11. You can take out an x plus 3 would be left. And then you can take out a 3, x plus 3. The x plus 3's would cancel, and you have just x over 3. Okay? My screen here doesn't tell me how much time we're on, but I think I'm doing okay on time. We got, looks like 8 more. Number 12. Factorable, you can take out an x minus 5. Factorable in the denominator, you can take out a 5, which would leave you with x minus 5. The x minus 5's would cancel, and you have just x over 5. That's simplified. Okay, now we're going to shift gears a little bit again. Number 13 is factorable. The numerator is factorable in your traditional factoring methods. If you factor by grouping, do that. If you factor, well, I should say that. We really didn't factor by grouping when this number was 1, so probably you don't factor by grouping. If it's something other than 1 and you were one who factored by grouping back in chapter 8, keep doing that. The denominator is a difference of squares. So both of these are factorable. Actually, that's not wise to put it there. Let me see if I can squeeze it over here. And this would be x plus 1, and this would be x plus 12. 1 and 12 give you 12. 1 and 12 add up to 13. This would be x minus 12, x plus 12. Remember, a difference of squares. The x plus 12s will simplify, and you have just x plus 1 over x minus 12. I made the point earlier that you don't really need the parentheses there. If you did, it wouldn't be wrong. If you put parentheses around, that wouldn't be wrong, but there's no need for them. 14, the difference of squares is in the numerator this time. Here you have x plus 3, x minus 3. In the denominator, you have just GCF factoring. You can take out an x squared, which would leave you with x minus 3. The x minus 3's would simplify, and you have x plus 3 over x squared. Okay? 15. The numerator, you have x squared as a GCF that you can factor out. That's what you should always look for first. See if you can get a GCF. You look at this and you go, cubed, we didn't really factor anything that was cubed. Well, we did when you could factor it out right away so that it's no longer a cube, right? If you could factor a GCF out and bring that degree down, yes, we absolutely did do that in chapter 8. X squared, dividing it out would leave me with x plus 1. The denominator is also x plus 1. Again, don't really need the parentheses, but do recognize that a fraction bar is a grouping symbol, so it's like there are parentheses, and these would simplify. So you have just x squared. 16. All right, so here we're going to get a little bit tricky. Okay, now you look at these and you think there's nothing there that would really simplify. It's two terms. If you're looking at this correctly, even you should look at this and go, there are two terms. So I can't just wipe out the 2y with the 2y and the 3x with the 3x, right? You can't do that. You can do it when it's a product like we did up above here, but not when it's a difference or a sum. Okay, here we have a difference. So you might, at a glance, think there's nothing that can be done here. Okay, but there is one thing that can be done, and that is what you would get if you would divide out a negative 1. You notice how similar those terms are, right? 3x, negative 3x, negative 2y, positive 2y. So if, for example, I divided out a negative 1 from 3x minus 2y, that would change the signs to be negative 3x plus 2y over 2y minus 3x, or if I rewrote that the other way around, just commutative properties, switch them around, negative 3x plus 2y. These are actually the same thing, and this would simplify down to just negative 1. Okay? Now, by the way, if you left this as 3x minus 2y in the numerator, and you factored out a negative 1 in the denominator, you'd have negative 2y plus 3x. Okay, or again, you could flip those around to make it look identical to this. Just flipping them around by the commutative property, that's allowed. And yes, they would cancel. And now you've got 1 over negative 1, which is negative 1. Okay. We're going to do 17, 19, and 23. So 3 to go. 17 is factorable. Looks like x and x. Looks like 2 and 3. Give you 6, we want the difference to be positive 1, so that would make this plus and this minus. I didn't do this ahead of time, I'm really just doing this in real time here. Factoring the bottom one, x and x got to be 1 and 2, and the 2 should be negative, and the 1 should be positive. Okay, so here, the x minus 2's would simplify, and now you have x plus 3 over x plus 1. Okay, 19. All right, now watch what happens here. I can take out a GCF, which would be 2, and then you'd be left with x squared minus 4. Oh, but wait a minute, that's a difference of squares, so we're going to be able to factor that again. Do that in just a second. The bottom one is going to factor as well, and that would be x and x. 1 and 2 both negative. Okay, so to factor that further, let me use some space over here. That's going to be 2 times x plus 2 times x minus 2 over x minus 1 times x minus 2. Okay, so what simplifies here would be the x minus 2's. And certainly you could leave this as factored 2 times x plus 2 over x minus 1. Yes, you do need the parentheses here if you're going to write it that way. No need for the parentheses in the bottom since that's it, right? X minus 1 is, that is the expression. If you did factor the 2, that would be fine. 2x plus 4 over x minus 1. In Algebra 2, it does just kind of depend on what the concept is, whether we want it in factored form or in standard form, and we'll tell you which is when. All right, 23. One more that's kind of tricky the way this one was, where we had to divide out the negative. Because 9 minus x squared, well, it is a difference of squares. If you were to factor it just like that, that would be 3 minus x, 3 plus x. We really didn't deal much with those, okay? So what I'd rather do instead is divide out a negative 1 first, and then it would be negative 9 plus x squared, or if I flip those around, how about x squared minus 9? There's a difference of squares that we would be used to, okay? And then I'll just rewrite this one now and factor it next, okay? So this would be negative 1. Don't forget the negative 1. It's got to be part of it, right? So bring that along, and this would be x plus 3, x minus 3 over, factoring this, clearly 3 and 4, right? The 4 should be positive. So we have the x minus 3's canceling. And again, you could leave this as negative 1 times x plus 3. I have a tendency that when the multiplier is negative 1 to just make the fraction negative. I'm not sure that that's even what the book would do. Okay, so if you gave me negative 1 parenthesis x plus 3 all over x plus 4, that's fine too. But when it's a negative like that, sometimes I just make the fraction negative, and it's negative the fraction x plus 3 over x plus 4. Okay, that's it. Good luck on your homework. Thanks for tuning in.